Hi, this is video 2 of the Surface Engineering Lab Demonstration series. In this video, we will be talking about hardness measurements. So, first of all, what is hardness? Hardness is the resistance of a material to local plastic deformation. The way in which we measure hardness is by using a diamond indenter of specific geometry, typically in surface engineering being either a Vickers or a Knoop indenter. As you can see, these indenters have a slightly different geometry, where the Vickers has a square indent and the Knoop produces an elongated indent. The indenter you select will depend upon what it is you are testing. For example, if you have a thin area you wish to test, such as for thin surface treatments, the Knoop would be better suited. However, due to human error with manual equipment, the Vickers indenter is more accurate than the Knoop. The machine here, which is also the one shown in this video, has a Vickers indenter fitted. The first step in testing your sample is of course loading it onto the machine. Whilst you are doing this, it is important to think about what load you wish to apply to the sample, as although a larger load will provide you with a larger indent, making for easier and therefore more accurate measuring, the resultant indent is influenced by a stress field zone of approximately 10 times the indent depth. So if you are measuring the hardness of a surface layer, the underlying bulk material is more likely to influence your result. Once you have applied the desired load to the sample with the indenter tip, the next step is to measure the size of the indent to enable the hardness calculation. As you can see, you will need to measure the width of your indent in both orientations. And then once you have done this, the machine will use these to calculate the hardness value using the equation shown here. Not only can you measure the surface hardness of a sample, but if you create a cross-section of your sample, you can also measure the variance in hardness value along this cross-section, where with diffusion-based treatments, you will see a gradual reduction in hardness value with increasing depth, as shown here, where increasing from temperature 1 to 2 to 3 resulted in increasing diffusion depth. As well as the previously mentioned penetration depth stress field, there is also one perpendicular to the indent, where the indents must be spaced at least 2 times the width of the indent to stop interference in the result.